Problems number 31 to 33. We have thin uniform thin rod has mass m and length l. Let the acceleration due to gravity is g. Let the rotational inertia of the rod about its center is I equal md square. So first problem number 31. Find the ratio L over D. So this problem we can solve if we know that moment of inertia equal 1 over 12 m L square, which is equal m d square, and from here we see that L over D equal root from 12, which is 2 root 3, and correct answer is D. Problem number 32. Now the rod is suspended from point at distance kd from the center. This point, this distance kd, and undergoes small oscillations with the angular frequency omega equal beta root g over d. We need to find what is beta, coefficient beta, in terms of k. So to solve this problem we need to write equation for rotation around this point. For rotation we have formula that I alpha equal negative force, which is mg, multiplied by level arm, which is kd multiplied by sine theta. Kd multiplied by sine theta. So for small oscillations we assume that sine theta approximately equal theta. To count what is I around point on distance kd, we can use parallel axis theorem, from which we have I equal md square, that's I0, plus mkd square. And finally rewrite this equation in form of md square plus mkd square multiplied by alpha equal negative mg kd theta. This part we can move to the right, and we have alpha equal negative k over 1 plus k square g over d theta. If you look at this equation, that's exactly an equation for a small harmonic oscillation. In that case, this coefficient exactly equal to omega square, and we can write omega equal root k over 1 plus k square root g over d. And finally this is our coefficient beta, which is none of them. Correct answer is E. Problem number 33. In previous problem we found what is a coefficient beta. In this problem we need to find what is a maximum for this coefficient. So to find the maximum for this function, we need to find maximum for function k over 1 plus k square, or to faster solve this problem, we need to find, we can flip this function and find minimum for this function. We need to take first derivative for that. That's 1 minus 1 over k square, and equalize it to 0, so which is k equal 1 and beta equal 1 over root 2, which is C, correct answer.